recently looked at the sun from this book, and now today we will look at Mercury through Pluto. And of course, this book was written in 1980, so it still thinks Pluto is indeed a planet, but it does leave room for perhaps being a double planet, so we will see that. Let's begin with Mercury, the first planet. Page 69. And we have arrived at the swiftest planet, Mercury, and we have a nice little drawing there. We have some nice illustrations. Let's see what it says. The revolution, which is one day, is actually 88 Earth days. So that's no, I misread that, or misunderstood. So it takes 59 of our days to equal one day on Mercury. And let's see, Mercury takes 88 Earth days to go around the sun. And let's see if we can find some other interesting facts about Mercury. Here is really interesting. So Mercury this is what the sunrise would look like, or a day would look like on Mercury. The Mercury day takes 59 Earth days. So it would take 22 days just to reach mid-morning, and there would be a roughly 200 centigrade temperature difference increase. And then I think I'll use a pencil. Get my ugly hand out of there. And then it would rise another mere 400 degrees centigrade by the time it reached noon. 44 days after the beginning of the sunrise. And Mercury's rocky rind hides an iron core about as big as the moon, twice as iron-rich as any other planet. Mercury is almost as dense as Earth, and that makes its gravity about a third of that of Earth, though its mass is only 1/18 of what Earth's is. This is what a asteroid impact would look like on Mercury. Here is how a scar is born on Mercury's cratered face as a meteoroid slams down. Here's as they say, an autograph. I've never heard it called that, of a meteor. Degas crater stretches its rays from a 45-kilometer wide pit, and rays from the impact formed when ejected material settled to the surface. Rayed craters here don't match the moon's, for Mercury's gravity is twice as strong, so debris doesn't fly as far. Impact. Here are the steps of the impact. Some shoots out in bands. Try to stretch this so you guys can see it. It's like umbrella ribs. Much is still moving outward as the pit reaches its final size. Right there. And down here we have Ray's mark where the ribs landed as the crater collapses in time. Sorry if that's kind of bright. And then here we have an indication of what oscillations would occur within the body of Mercury if a meteorite hit. Surface waves would make their way around the crust in compression waves. Would radiate through the center of Mercury. Here's a nice artist's drawing, and I like that these are all apparently hand crafted art pieces throughout this book in the 80s because the computer graphics weren't all that good, and I think there's almost more beauty to it rather than the really cold, super sharp computer graphics. There's a lot more details to it that a computer really can't create, I don't think. Here it says, from some spots on Mercury, we could see the sunrise twice. Because, I guess because as it's going around the sun, it's rotating so slowly that it would in fact catch up to the sun at some point. And so the sun would do what the other planets, Mars and Venus, look to do from Earth, which is go and then make a loop back and then continue their path. Alright, one planet down. Venus, a veiled planet. Venus's upper clouds of poisonous sulfuric acid swirl in a pattern of yellowish mists. Here we have another set of beautiful drawings. Venus traces an orbit that is closer to a perfect circle than any other planets, and yet it moves in odd ways. Its rotation is retrograde, or backward, so the sun rises in the west and sets in the east. That spin is so slow that 4 Earth months go by between only one Venus sunrise and the next. You know, I didn't know that. Mercury and Venus both have very long days. It's really weird. You can only imagine what really chaotic events led to either Earth slowing down or speeding up, or Venus slowing down in their rotations. Here, 3 blankets of cloud. The top one, thin and hazy, wrap Venus and perhaps help to keep it warm. Earth knows no clouds like these. Their droplets are sulfuric acid. Their snowflakes, still mysterious. Sunlight filtering through them may add to the intense surface. Let's see. So we have layers here, 68 kilometers, 55 kilometers, 50 kilometers, 48 kilometers, and down here 31 kilometers. The upper winds at the top, 350 kilometers an hour, spread the heat fairly. Oh, that top. It's late. I'm making a lot of mistakes. Sorry, guys. 300. Wow. They top 350 kilometers, and they spread the heat fairly around the planet. Fairly and evenly. Down the surface, winds are calm at about 4 kilometers an hour. You'd move slowly too, for on Venus's surface, the carbon dioxide atmosphere is 91 times denser than Earth. That's very, very dense. And they are pretty close in size. See if you guys can see that. We got the short life awaits a Soviet Venera spacecraft, 1 of 8, that soft landed on Venus's brutal surface in the 1970s and early 80s. Even the hardiest lasted for only just 2 hours in temperatures high enough to melt lead and pressure 90 times that of Earth. that 4 craft took pictures of the stark terrain surrounding their landing sites. And this panorama looks down at the spacecraft's base and out towards Venus's horizon. And this is actually a pretty cool landscape. It's all red. It's got that Martian tint, but a very dense, very energetic atmosphere of Venus, perhaps Earth too. Raining down sulfur. That sounds pretty terrible. And over here we have a little chart that shows the increase in wind speed with the increase in altitude. Venus knows only one wind direction, and that's westward. Night or day, near equator or pole, its entire atmosphere moves in the same direction. Cloud patterns unseen by visible light leap into view at these colored ultraviolet photos from an orbiting Pioneer spacecraft. I like that sound. And I'm not particularly interested in names of things. I like to know what they are, like physically, like Richard Feynman. You could call a bird the same bird 5 different names. And that still won't really tell you anything about it. Its mating habits, its sounds, its migration locations. I suppose that was a nice segue. That was a not half bad segue to Earth. Whoa, that's very cool. Length of day, or the rotation here, 23 hours and 56 minutes. Earth falls within the region of tolerance called the ecosphere, in this safety zone, which extends roughly from the orbit of Venus to that of Mars. The temperature doesn't get too hot or too cold. And here our layered atmosphere presses down on Earth. Most of our weather occurs in the troposphere. And here is the troposphere. It's hidden below the stratosphere, where we see those feathered clouds. In the mesosphere, the thermosphere, where we see the auroras, and the exosphere, which all those three make up the ionosphere, I guess. Here the magnetic field. It acts as our shield against the solar wind, creating a region called the magnetosphere. The wind carries deadly electrically charged particles as it streams outward from the sun. Some particles are trapped in the Van Allen radiation belt. Two bands that sort of like donuts circle the Earth. Wow. And if any of you guys have a TV, this just made me realize this, that streams YouTube. You can stream a sort of live image, video. Very, very, very cool. From the space station circling Earth. And you pretty much have this same view right around here. It's very, very, very cool. I think this was they believe this is how the plate tectonics have evolved the continental masses over the last 200 million years. Some lava, some more pictures that really, this could be Venus, for all we know. It might have been millions of years ago. And then here, it's really cool. One, I like the lightning and the ocean flooding in. Or maybe that's a river. Flash flood. Here's what life on Earth may, presumably, have resembled 150 million years ago. Saw lush vegetation and many forms of reptiles. Wow, that's really cool. Hurricane Gladys. Photographed by the Apollo 7 astronauts. Swirls over the Gulf of Mexico. I can't really make out any land, so I don't really know where in the Gulf of Mexico it is, but it definitely looks like it's got a very weird elevated eye. I never knew they were elevated above the rest of the clouds like that. It's like the inner circle is higher up than the rest, but I guess in a way that wouldn't surprise me, I guess. And the movement is counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. I suppose that has to do with the general direction of the trade winds. I don't know. And this looks like it might be able to shed some light on that. Sun sends about 99%, 99.9% of the energy needed to heat the land, oceans, and atmosphere, 3 important factors in creating weather and climate. Here a layer of ozone concentrated about 20 to 35 kilometers above Earth, absorbs most of the sun's harmful ultraviolet rays. Those that get through tan or sunburn us. So it's actually those invisible ultraviolet rays that cause us to get sunburned. Mountain ranges, such as the Andes in South America here, deflect air currents. The resulting swirls of wind can affect weather hundreds of miles away. More sunlight reaches Earth near the equator than at the poles. All air warmed at the equator rises and flows towards the poles, where it cools and descends. So it gets hot, rises up, cools towards the poles, and then descends, working its way back. The cells. Where am I? Where it cools and descends, creating 3 cells of moving air in the northern hemisphere and 3 cells in the southern hemisphere. The cells control great air circulation patterns that form the prevailing winds, the trade winds in the Hadley cells. That's these right here. Work like that. And the polar easterlies in the polar cells. Deflection in the Ferrel cells causes the prevailing westerlies. It's pretty cool. And then up here, solar rays reflected from snow, ice, and clouds affect the amount of heat that stays near the Earth's surface. Open water, land, and the atmosphere absorb as well as reflect the solar energy. Fine ash carried from erupting volcanoes to the upper atmosphere can cool Earth by reflecting some of the incoming solar heat. Air pollution can cause global changes in our climate. When burned, fossil fuels like coal and oil release carbon dioxide and other chemical particles. They may form a blanket in the atmosphere, trapping surface heat, infrared rays that normally would radiate back into space. This greenhouse effect can raise the overall temperatures of the atmosphere. Then here, Earth's oceans store and transport heat. The Gulf Stream flows far north, keeping the climate of Europe moderate. Oh, I didn't know that. Oh, and then we have the Labrador Current all the way up here. You can see near Newfoundland. I got some family there. And yeah, the water up there is always cold. The ocean water up there, it never gets warm. It's very, very cold. I remember kayaking off Newfoundland one time and my water bottle started getting kind of warm. I dunked it in the ocean for maybe, I don't know, a minute, and it was literally ice cold. Ice cold after that. Like instant freezing. I love that sound. Those sounds are, I love it. Marktica, he's really good at doing that, especially when he draws. When he's drawing the maps, those are the best. And then the desert winds raise dust and blow it long distances over the subtropics. This dust sometimes blocks solar rays, causing temperatures to fall temporarily. Okay. Whoa. Looks like Niagara Falls or something. It's a lot of water. Although, and I'm still going to do an episode on it because I actually got some requests to do some geology and some early ancient, perhaps pre-Ice Age, pre-10,000 BC civilizations, and I think those two line up. They overlap because there might have been a meteor impact near the north in Canada or Russia area that generated so much heat that it melted all the ice caps on all the cap ice in the poles and caused a rush of water that within 2 or 3 weeks, I think, that from what I heard from Randall Carlson and Graham Hancock, was equivalent to about, I forget the exact number, but I remember it was unfathomably a long, long time. And they were saying the amount of water that actually rushed over North America alone at that time, that they used drones to spot the gouges of the actual geological evidence. they say that it was equivalent to like 1,000 or maybe 5,000 years, or maybe not that long. Maybe it's like 200 years, but still, the amount of water that goes over the Niagara Falls in 200 years is a lot. And they say that same amount, rushed down the entire face of North America in a period of days, maybe weeks. So I'd like to talk about that in depth, do my research for you guys if you're interested. And I think a couple of you are. So I'll absolutely do it, but I guess I'll do it a little faster if I get any feedback from you guys from this video. Here, North America, Hudson Bay, Canadian Shield, Asia, Sea of Okhotsk, the Bering Sea, the Aleutian Trench, and I know I said I didn't care about names, but we live here, so I know some of these places. I guess the Marianas Trench. I guess the deepest place on Earth is 11 kilometers deep below sea level. That's very, very deep. And then the Pacific Ocean, containing 46% of Earth's water. And look at these ridges, fracture zones. This is pretty cool. I guess they're called fracture zones. I don't think I've ever noticed that before. Maybe I just wasn't paying attention. And the Hawaiian Ridge, and volcanoes rising above the waters. Submerged volcanoes are known as seamounts. That was a very nostalgic little trip right there. Ports of Canada has a song that uses the voiceover from one of the scientific videos that sound very 80s, 70s-ish, that they actually got their name from, I think. The National Film Boards of Canada. Mid-oceanic ridge. So this is a more on top view of Earth. And this is a obviously bottom view. And here is ASM Arctica, or his opposite, I guess. Actually, over 90% of Earth's total volume of ice is in Antarctica. Many small ridges form the mid-oceanic ridge, 64,000 kilometers, Earth's longest feature. I guess that's what that is. I guess they consider it all one structure. And the Kalahari, Sahara, Arabian Peninsula, the Red Sea, Gulf of Aden, cool. I think that's enough of that. I want to get to Mars, like Elon Musk. Which, by the way, I'm recording this the day before the Falcon Heavy launches, so I guess he's actually gonna send his Tesla to Mars, which is, I don't care who you are, but that is cool. That is really, really cool. Sending a convertible car to Mars. Or no, actually, I think, I don't know, I didn't get all the details, but I think he was actually doing like a Voyager kind of mission, where he sends it into deep space. Here's a nice little lesson. Neap tides are when they are the most even around Earth, because the forces even each other out. The sun's force is pretty much perpendicular, or maybe exactly. That's probably what defines what a neap tide is, and it evens the forces out. So the sun pulling that way, moon pulling that way. And then when they team up, you can see here, that creates very accentuated tides, a bulge of water, kind of like on Interstellar, which I thought that whole scene on Interstellar, I thought was a bit much. Probably should have made the wave a little more round, more of a bulge, less of a peaky wave. So, alright. Did not realize they were going to do our moon, but hope I don't run out of space. Here we have, that's a cool way to look at the trail that the moon follows. Very cool. So it, you know what? I never actually knew that. Is that really what it does? It orbits. Wait a minute. No, it doesn't. Okay. I was thinking that meant that it orbits the poles, but of course it doesn't. It orbits this way, around the equator. Yeah, that would that really threw me off there for a second. And these are all the names of the moons here. And they think that the moon might have an iron core, has 1/6 the gravity of Earth, and this is representative of I guess this would be a solar eclipse, and then that would be a lunar eclipse. Oh, this is cool. The moon and the earth, tied together by gravitational attraction, revolve as a double planet. Think of them as unequal ends of a weightlifter's barbell. And because Earth's mass is 81 times greater, the center of gravity of the Earth-Moon barbell lies about 1,700 kilometers below the Earth's surface. It's called the Berry Center. And here the pivotal point, the pivot point, not Earth's geographic center, follows the smooth orbital line. It's the thick blue line. A lot more smoothly than I am doing it. But good Lord, I love that sound so much. Going crazy with it. As the barbell spins around its center, its eccentric center of gravity, both Earth and Moon trace wobbly orbital paths through space. Right through space. Okay. And the Moon rises an average of 50 minutes later each night. During the new phase, Moon and Sun rise and set at the same time. From then on, the Moon appears in different parts of the sky. In the west, as it waxes larger towards gibbous, which is hump-shaped. In the east, as it wanes smaller, much smaller. Okay. And here we go, the far side of the Moon, sometimes the dark. First seen in photographs taken by unmanned space vehicles, reveals a surface heavily pitted with craters, which makes sense that it would be more heavily pitted on the outside, because Earth would probably prevent impacts on the inside facing Earth. I really, really like this picture here. This picture. Split rock dwarfs U.S. astronaut Harrison Schmitt east of Mare Serenitatis on the moon's near side. Schmitt holds a gnomon. This picture was taken in 1972. And it was actually the final Apollo mission. Okay. final Apollo mission. Wow. The moon's night side temperature drops to about negative 170 below the surface. Below centigrade. Oh. And I guess Mare Serenitas. I still laugh when I say it. I don't know why. It's because I'm embarrassed. I can't pronounce it right. I guess that's where they took that picture. Where's Tranquility Bay? I'm sure it's here somewhere. Or it is out. Is it out here? I can't see it. Do you? Do you see it? Maybe it's not in this picture. Yeah, I don't think it is. Wow, and there is the iconic picture. Alright guys, it looks like I am completely out of film. And I have been filming for a while, so we won't get to Mars, but I'll either do a standalone Mars episode, or we'll just lump it in with the asteroid belt and the gas giants. Night, guys.